Zhao Liam, episode 3 of 6, two instruments in this episode, and they attack the two places a build hides mistakes. The robustness probe attacks the model. It asks what the model actually learned by testing whether removing or perturbing specific inputs breaks the predictions. The data frame audit attacks the data. It asks what the data actually is by reconstructing the decisions that produced it. The loop is identical for both. Predict. Run the instrument on your own work, report what it exposed, name the fix and the residual risk. Pick whichever fits your artifact or run both for the stretch. If your build is a prompt-based system or an agent, the robustness probe applies directly, with authority escalation and tool surface variance. If your build is a classifier or dataset, either instrument applies. The data your model never questioned is the data most likely to be the problem. The robustness probe suite requires at least 3 probes. Probe 1, the perturbation probe. Make a small change to the input, swap a synonymous word, shift a numeric value by 10%, alter a date by 1 day, and check whether the output changes wildly in response. A model that reacts strongly to an irrelevant perturbation learned a surface-level pattern, not the underlying concept. Probe 2, the proxy-feature probe. Remove or scramble the feature you most suspect the model is using as a stand-in for something it should not be using. Did accuracy barely move? That is a finding. It means the model was not actually relying on what you thought it was, or it means the feature you removed was the proxy and the real signal is somewhere else in the data. Probe 3, the distribution shift probe. Test on a slice of the data that was underrepresented in training, a different time period. A different geographic region, a demographic group with fewer rows. For agent and prompt-based systems, add 2 more. An authority escalation probe, which asks what happens when the input claims elevated permissions or identity, and a tool surface probe, which asks what happens when the input attempts to redirect the agent to unintended tool use. The result of the probe suite is not a number, it is a robustness profile table. 3 columns, what the probe tested. What it found, the monitoring flag you would set in production. For each break in the probe suite, the features not bugs framing asks 3 questions. 1. What proxy did your build actually learn? Not what you intended it to learn, what the loss function rewarded it for learning, given the data you gave it. 2. What human relevant feature should it have used instead? The feature you intended named specifically. 3. What does the gap between the proxy and the real feature say about your training data? A classifier that used timestamp as a proxy for relevance did not make a mistake in the usual sense. It found a real pattern in the data. The timestamp genuinely correlated with relevance in the training distribution. That is the problem. The proxy worked, and that is exactly the failure mode. Your model will perform well in the training distribution and fail in the deployment distribution wherever the correlation breaks. The features not bugs framing is not about assigning blame. It is about naming the gap precisely enough to design a fix. If you removed the timestamp feature and accuracy barely moved, right? Proxy used timestamp, real feature, semantic relevance signal, gap. The correlation was an artifact of a specific time window and will break on data outside that window. That sentence is the robustness finding. Data frame audit starts with a datasheet. Jebru's 5 questions adapted for your build. 1. Motivation, why was this dataset collected and by whom? 2. Composition, what does one row represent? What is and is not included? 3. Collection process, how were rows acquired, labeled, and joined? 4. Uses, what was this data intended for and what should it not be used for? 5. Distribution and maintenance, how is the data distributed to you? And who maintains it? Then the 6-step epistemic frame reconstruction. Step 1, why exactly in rows? Not I filtered it, but what decision produced that exact count? Step 2, what is not in the data? Name the concept or entity that cannot appear. Step 3, what is the time window and what changed at its edges? Step 4, what label proxy did you use and what real concept does it approximate? Step 5, where is the data MNAR? Missing not at random, where the absence itself is informative. An MNAR field is one where the missing rows are systematically different from the present rows, so imputing the missing values or ignoring them both produce the same bias. Step 6, what boundary assumption did you make? The assumption about what the data is allowed to say about. Then, trace one row end-to-end from its source to its prediction. Name one hidden failure that procedural exploratory data analysis would not catch. Plotto inward is the classical move for the data frame audit. The question is, what is the artifact you made versus the world it claims to describe? Your rows are not the population, your labels are proxies for real concepts. Your boundary assumptions are invisible until someone outside the window asks a question inside it. The exercise is to write one sentence specifically. My artifact describes what I actually have, not what I claimed it describes. Here is an example. My loan default classifier describes the repayment behavior of approved applicants from a single regional lender between 2022 and 2023, not the creditworthiness of the general population. That sentence does 4 things. It names the artifact, it names what the data actually is, it names what the claim implies but the data cannot support, and it makes the boundary assumption explicit. If you cannot write that sentence, the data frame audit is not done. If the sentence is uncomfortable to write, it is especially not done. Write it anyway. The discomfort is the finding. Verdict for probe the model and its data, robustness and the data frame. Probe suite requires at least 3 probes: perturbation, proxy-feature, and distribution shift. For agent and prompt systems, add authority escalation and tool surface probes. The result is a robustness profile table, not a number: 3 columns: tested, found, monitoring, flag. Features not bugs names the proxy actually learned, the real feature that should have been used. And the gap that explains where the correlation came from. Data frame audit, Jebru's 5-question datasheet plus 6-step epistemic frame reconstruction. MNAR is the field where absence is informative, 1 row trace end-to-end, 1 hidden failure EDA would not catch. Plotto sentence written, my artifact describes what I have, not what I claimed. Your turn, here is the prompt. The prompt reads, I have a artifact type, for example, a lone default classifier. My top features are list your top 5 to 10 features by importance or coefficient magnitude. I suspect my model is leaning on specific feature, for example, account age as a proxy for real concept, for example, financial stability. Help me design a proxy feature probe. What exactly should I remove or scramble? Move the feature entirely from the test set, or scramble it by randomly permuting its values. How should I run the before and after comparison, and what result would confirm the proxy hypothesis versus refute it? A result that confirms. Accuracy drops significantly when I remove or scramble the feature, even on inputs where the feature seems irrelevant. A result that refutes. Accuracy is stable across the scrambled version, meaning the model was not relying on it. Also, my data has described your MNAR situation, for example. Income is missing for applicants who chose not to disclose, and those applicants are systematically higher risk. Name 1 hidden failure that my exploratory data analysis would not catch given this MNAR pattern. After you get the probe design and the MNAR failure, run the probe as designed. The result, not the hypothesis, goes in the instrument report. Probe the model and its data, robustness plus the data frame. Liam in for bear.